So the last type of pattern at year 11 is exponential patterns, and this is high merit and excellence only. A pattern is exponential is that the difference between one term and the next is a constant multiplier. So for example, we have the sequence here. If we look at the differences between each term, then goes 2, 6, 18, 54. If it was a quadratic pattern, then the difference between this one and this one, which is 4, would be the same here, but it's not, because the difference is 4, the difference is 12, the difference is 26. So it's not a quadratic pattern. Instead, what's happening is it's going up in a constant multiplication. So this is the base formula for any exponential pattern, and all exponential patterns can be written in the form of one number times the base to the power of x. The b is the multiplying portion, effectively the gradient part, and a is the zero term, so that's the same as when we do linear. We have a difference and a zero term, except this time it's multiplications, not additions. Let's see how it happens in practice. So we have a sequence 6, 18, 54, 162, and that's going up in multiples of 3. 3 6 is 18, 3 18s is 54, 3 54s is 162, and so our base here is 3. Well, 3 to the 1 is 3, but we've got 6, so we need a correction factor here. If we take 3 and go back one term, then we would get a 2, and so that's our formula. It's 2 times 3 to the x. The 3 is the multiplication, the 2 corrects the starting point. Do it again, it's the same every time. So this is going up in multiples of 4, so the base is 4. But 4 to the 1 is 4, not 1. If we go back, we see we need a correction factor of a quarter, because a quarter times 4 to the 1 is 1. Those of you who have decent amounts of algebra recognize that we can take this quarter and stick it in the power, because a quarter is 4 to the minus 1. So we can write it that way. As often as not, that's actually how it will occur. So last example, seeing it done the other way. Here is our increase, it's going up in 2s. But if we notice, the pattern 2 to the x, ignoring the a, the pattern 2 to the x is 2, 4, 8, 16. So the pattern has just been drifted across 2 places. 8, 16, 32, 64. This would be 8, 16, 32, 64. So our pattern 2 to the x is drifted off 2 places. It's been moved 2 down, so we can correct in the power rather than with the a. So this a thing gets written up into here, because this number here would be 4, it's 2 to the 2. Half the time that's what's going to happen as well. So to recap, an exponential pattern is one of the form a times b to the x, where the b is a multiplier from one term and a is the correction that makes all the terms correct, which we can find by going to the zero term. If the a is a multiple of the b, then we can move it into the power. When you have a pattern that is not linear and not quadratic at year 11, then it must be an exponential pattern. So you don't need to really look very hard. Is it linear? It's a constant difference. Is it quadratic? Constant difference of the difference. If it's not, then it must be an exponential pattern. So you really just have to go and find what the multiplier is by dividing one term by the next, and that gives us our b. The a then corrects for each term.